Hello and welcome to the Conway Cube demo, which is now fully working after a lot more work than fully expected. As you can see, this is working at a good frequency. The frequency you see here is not due to FPS limitations, but instead is due to the tick resolution, which I believe is 400 milliseconds, meaning we still have an FPS of 70. So, yep, that is working. It's running all the rules. I'll walk through that shortly. This is a grid of 1,000 units, of which the render mesh is being toggled on and off, according to the rule system. The other thing to add is this is now using branching logic, which I'll now go through. Pause this for a second over here. So this is all procedural logic. None of it is, in code, so to speak. And so therefore it's proving the number of units we could do more complex logic with. So I zoom in here. From the top, these are all our variables. No point in explaining that right now. We have implicators, which scan for values, and then when the value matches, calls a game task, for example, toggle render unit mesh. And then if that succeeds, it then passes back the output from that game task into some keys, for example, current render state, that kind of thing. The more interesting one in this case is the action tree. So these are logic operators that input keys. They look at the values of those keys, output the result of that logic to that output value at that key. And you can see execution order 0. And how we get branching behavior is, for example, here, if should update render is true, skip all logic until it's false, and rules should be applied again. So in this case, pass to outputs. So that means it's going to pass should update render into nothing. However, the output of that, if it's true, it will jump to index 8. If you go down to index 8, you can see apply next alive state 8. So it's going to apply the next thing. And you can see here each rule in the Conway is game of life. So that's rule number 1. So any live cell with fewer than 2 live neighbors dies. Again, if that is successful, set next to live state to false. Therefore, we do jump again. Same thing for rule number 2. Any live cell with 2 or 3 neighbors lives on to next generation, and any live cell with more than 3 live neighbors dies by overpopulation. And finally, any dead cell with actually 3 live neighbors dies, becomes a live cell as if by reproduction. So total amount of XML here is 500. It was designed in the editor tools, so no programming skill even needed to create the XML unless you want to edit it manually. And yeah, that's the result. Thanks for listening. Have a good evening.